faculty at the DC field at Magnet Lab in FSU. I started in August of last year, so I'm still relatively new, but I'm not new to the Magnet Lab family because I used to come to Magnet Lab as a graduate student doing my experiments. Then I was a postdoc at the Pulse Field facility of Mag Lab at Los Alamos, so I've been kind of part of this family for a while. I'm a researcher, so part of my responsibility is doing my research. I'm a condensed matter physicist, so I study materials, I stick them in high magnetic fields or squeeze them really hard, so high pressures, very low temperatures, sort of torture them to find out what fun things we can learn about these materials. Part of my responsibility is also user support. Like I said, DC Field is National Science Foundation funded facility. It's for users, so people nationally, internationally come in here, do their experiments, and I, as a user support scientist, support their science, so help them in whichever way to make their experiments work, their research go where they want it to. So that kind of in a nutshell is what my day-to-day looks like. I graduated from University of Kentucky. As a graduate student, part of my research was, growing new materials. So we're synthesizing new materials, which would also be part of research that I'll be doing here at Magnet Lab. And like I said, we do not have or did not have access to such high magnetic fields in our home institute, right? So we used to come here to use the record-breaking 45, or record holder right now because it's the highest DC field on Earth. So the 45 Tesla, do our experiments, go back home and publish. I did my postdoc at Argonne National Lab doing X-ray studies, and then I moved to the Pulse Field facility, like I said, at Los Alamos, which is the Pulse Field facility of Magnet Lab. So I was a postdoc there, and I traveled to this facility also to do experiments. So like I said, being closely kind of related to the whole time to being at Magnet Lab and FSU. And I think this is a really great place to be because you have world-class research going right here at your doorstep. So you get to meet all kinds of researchers in different fields. So this is your window to what's happening out there. You get to meet them, you talk about their science, you think about your own science. Specifically the Magnet Lab, yes. And then FSU is great. Tallahassee is, especially with families with small children, I think it's a good place to be. Work-wise, I cannot think of a better place, research-wise for me, career-wise, because the way I see my career going, where my research going, I have all the tools and equipments and expertise right here with me. So I think it makes it really, I wouldn't say easy, but it helps with the challenge. And so FSU, we have a great physics department, especially condensed matter, which are mostly housed in the Magnet Lab. So we have access to that collaboratively, and it's a great group to be working with. I want to establish a group, a world-class group, with research, and I think I have a good track record. I want to make it better, and just having the facility right here. I am at the facility. I have the highest magnetic fields right here, which makes it easier for me to access, which makes it easier for me to design my experiments, and to figure out what new science I'm doing. So part of being a condensed matter physicist nowadays is basically you should be able to adapt. So you're starting with one kind of research, you start with a particular material, and then you realize it's just it leads to another one that you're not familiar with, but it's kind of a very obvious transition to a different one. We have theorists, we have experimentalists, we have great scientists and researchers right here, so that helps with collaborations, making those dreams sort of reality to make that happen. So yeah, I'm looking forward to it. So I have been working recently in multiferroic materials, and these are materials where the magnetic ordering and electric ordering happen at the same time, in the same phase, and it's rare. It does not happen. There are some materials who want to order magnetically, there are some who want to order electrically, but to happen at the same time, at the same place is kind of very interesting and very rare. So that's the research I'm still doing. and I have been doing at Los Alamos. But broadly, I study what you call oxides, ceramics that you know. So these are materials which contain oxygen, and they are very fun materials because you get very interesting signs like superconductivity. So you have a current going through material which never dies ideally, or you have many, many orders of change in the resistance of the material when you apply magnetic fields. So all those things do not happen in your normal day-to-day materials. So we make these oxides, these are novel, then we find out what's the fun sign. So that kind of ties in from what I've been doing as a graduate student to postdoc to being here, and then the way I see it continuing is growing newer materials. So crystal synthesis is going to be one part of my research here, and then looking for new novel physics in oxide-based materials. One of the best part is just being surrounded by people who are so good at what they do, especially in physics and in condensed matter physics. There are people, have theoretical theorists who are there when I have to brainstorm. There are experiments, there are scientists who've been here for years, and when like thinking about an idea, I can just go stop someone and say, hey, what do you think about this? And to have that right there, because I've been in universities, and there are times when you're like, I'm not sure if I'm able to talk the same language, speak the same thing, have the same idea come across, because there are good people everywhere, but these are people who are talking my language. These are people that I can brainstorm right away, and it's right here. I do not have to wait. I do not have to go, find them somewhere in different institutes. In fact, they come to us, so all the international users, researchers coming, bringing all of that fun research right here. So, and FSU is a great place for that. Mag Lab is a great place for that, to sort of, make it happen. Campus is great, let me say that. I don't get many chances to go over there, but I do go for like some talks and stuff. Except the parking, everything else is really cool. There are good food places around, which makes it fun. Like I said, the city is good for, especially when you're new faculty, you usually have new families, usually, not always, but their museums, the music department at FSU is great. Just so I know, they have these dress rehearsals free. I took my son there, and that was very fun. But like specifically, I would say Mag Lab and FSU, that's, it's a great equation for somebody willing to go further in their career, looking to, go beyond what you know now, like look for new things, have that groundbreaking science going on. And I think you have the support. For the new faculty orientation, I realized, and so if I'm writing a grant as a scientist, there is support for that. There is the Office of Research, there is the Office of Faculty Research and Development, and people are willing to work with you to, take you to where you want to go and maybe beyond. No, Mag Lab is fun. I mean, I just cannot put it any other way. It always has been. I remember as a graduate student, I was like, oh, what would it be working here? I just didn't think it would happen at that point, but it was like, I used to come here, talk to the scientists, do these experiments with the big magnets. I'm like, it must be so much fun being a scientist here. And I can tell you it is.